In this question, we are asked to find out the conditions for interference. Uh, the arrangement is given as these are the two coherent sources S1 and S2. They are separated by distance 4 lambda, where lambda is the wavelength of the light. This is the screen, which is placed at a distance d, which is much larger than the distance between the sources. And we are required to find out that the distance y, this is the distance y between point O and point P, that distance y such that the intensity at this point P is the same as that at point O. So we are required to find out what is the distance, this distance between O and P, such that the intensity at P is equal to the intensity at O. Now, since the distance between the screen and the sources is very large, we can consider that this distance is almost the distance from the midpoint of these two sources. So, if we mark the angular position of this point source P from their midpoint, let's say this angular position is theta, then we can use this theta to find out the conditions for the interference at point P. Now, we want to find out the intensity should be the same as the intensity at O. So first, let's look at this point O. These two sources are on the same line as the line joining to the screen with point O. Then we can say that the path difference between the light waves which are reaching from S1 and S2 to point O, that should be equal to 4 lambda. Now, since this path difference is an integral multiple of lambda, we can say that the intensity at O will be maximum. For a path difference 4 lambda, the intensity at this point will be maximum. So we need to find out such points P where the intensity will be maximum other than point O. That is why it could be 0 if the point overlaps with O, and other some values of O. Other some values of Y. So let's start with the solution. Since the path difference at O is 4 lambda, point O is the maximum. Point O is the maximum. Thus, the intensity at point P should be maximum. Right. So we'll see what is the path difference of the light rays which are reaching point P. See, this angular position is theta and this distance is very large. So we can say that the path difference between these two lines is the path difference. This will be equal to 4 lambda cos theta. So I can say delta x, which is nothing but mod of S1p minus S2p, that is equal to 4 lambda cos theta. Now, since mod of cos theta is less than equal to 1, we can say mod of delta x will also be less than equal to 4 lambda. Right. Now, for maxima, delta x should be an integral multiple of lambda, where n belongs to integers, right? And for n equal to 0, P coincides with O, right? So we can say this is delta x. So we can say that delta x can be equal to, we will not take n equal to 0 since P coincides with O in that case. We will take some other values, not n equal to 0. This is for n equal to 4. N equal to 4. When n equal to 4, the path difference becomes 4 lambda, and that point P corresponds to this position. So we'll not take that position, but we can take other positions such that is uh, delta x is 0, or it is lambda, or 2 lambda, or 3 lambda, and we'll not take 4 lambda since P and O will coincide in that case. Now delta x is nothing but 4 lambda cos theta, so we can say 4 lambda mod of cos theta will be equal to 0 lambda, 2 lambda, 3 lambda, right? So this from here we get that cos theta will be equal to 0, 1 by 4, 1 by 2, 3 by 4. Now this position cos theta is 0. This position represents the position at infinity. So y can be infinity as well. For the other positions, the cos theta will be a cos inverse of 1 by 4, and this 1 by 2 and 1 by 3 by 4. For other positions, we can say that cos theta can be written as this is d, which is very large, and this is y. Right. So we can say cos theta will be, for this triangle, cos theta will be equal to d upon under root of d square plus y square. So cos theta can be written as d upon under root of d square plus y square. And squaring this, we get cos square theta is equal to d square upon d square plus y square, which will be equal to 0, 1 by 16, 1 by 4, and 9 by 16. Right. So from here we get y square will be either equal to 0 or 7d square by 9 or 3d square or 15d square. This is not 0, this is infinity. For cos theta, this will be cos theta 0 will be for y equal to infinity. So we can say the position of y can be position of y can be 0 for this point, or it can be under root of 7 by 9 d. This is plus or minus, then plus or minus root 3 d, or plus or minus root 15 d. Now this plus or minus represents the position which is above point O, that is positive, below point O, that will be negative. Now for linear sources, that is S1 and S2, if they are linear, these positions y, it represents points lying above and below O at these positions. And if the sources are point sources, these distances y, they'll represent the radius of the circular fringes which will be formed on the screen. So that is what is the solution of this question. Thank you.